Welcome viewers, in this video we will see the details about the half adder available in the digital electronics. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive, link is given in the description box. Now we will go to the topic. Before discussing the half adder, we will see the what is the basic about the adder. The digital computers perform various arithmetic operation. The most basic operation is the addition of two binary digits. The simple addition consists of 4 possible elementary operations, right? So the digital computer various arithmetic operation available. The most one is the addition of two binary digits. So because of two binary digit, we have 4 combinations are available. We will see these 4 combination. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. So first 3 operation is very simple. 0 plus 0 0, 0 plus 1 1, 1 plus 0 also 1. The fourth one 1 plus 1. So while adding 1 plus 1 we got 1 0, that is sum is 0, carry is 1, right? The carry is generated. First 3 the carry is not generated, fourth combination carry is generated. So we need to concentrate the carry also. So the two binary digits available, sum available and carry available. While generating the carry, it should be added with the next digit. So totally we need to concentrate 3 bits. The 2 bits are inputs and 1 bit is carry. The answer is sum. So practically we need a 3-bit adder, that is called a full adder. But in half adder we have 2-bit addition is there. In half adder we can perform 2-bit addition, but that is not practically possible. Practically we need 3-bit addition because 2 digits and 1 carry. But half adder is also still available. By using the half adder we can construct the full adder, right? So in this video we will see the details about half adder, right? So half adder will add 2 bits, but in practically we need 3-bit addition, that is performed by full adder. What is 3-bit? 2 bit is the input, 3rd bit is the carry, right? So in the first 3 the carry is not generated and operation also very simple. The fourth combination sum is generated as well as carry also generated. Now we will go to the half adder circuit. Now we will see the half adder. The half adder operation need 2 binary inputs. We already discussed the 2 binary inputs are added using the half adder. In full adder we are using 3 binary digits, that is 2 binary digit as a input, third one is the carry, right? So these two AND 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 bit are the 2 binary output, the binary inputs. The output is the sum and carry, right? So we will see this, what are the truth table for the half adder, right? The 2 inputs A and B. Because of 2 inputs we have 4 possible numbers are available: 0 0, 0 1, 1 0, 1 1. The outputs are sum and carry, right? So while adding 0 0 is the sum is 0, there is no carry. While adding 0 plus 1, the sum is 1, carry is 0. While adding 1 plus 0 also, the sum is 1, carry is 0. So while adding 1 plus 1, 1 plus 1 is the sum is 0, carry is generated, right? That is 1 plus 1 is nothing but a 2, right? The decimal equivalent is 2, that is 1 0, right? Carry 1, sum 0, right? So in the fourth case the carry is generated. So this is the block diagram. Half adder available. The inputs are A and B. The output is carry and sum. Now we need to implement this with the logic circuit. The output, the sum as well as carry, we need to generate the sum and carry using the logical circuit, right? What is the sum? What is the expression for sum? There is 2 ones are available here, right? So the correspondingly what is available here? 0 1. 0 1 means A bar B, right? Here also 1 is available. What is there correspondingly available? 1 0. 1 means A is 1 and B is 0. So that A B bar, right? So the sum is nothing but A bar B plus A B bar, right? So A B bar plus A bar B is nothing but a exclusive OR gate, right? So we can use the exclusive OR gate for the sum, right? So there 1 is available. The corresponding what the input here? 0 1. 0 1 means A bar B. This one is correspondingly 1 0 A B bar. So A bar B plus A B bar is nothing but exclusive OR gate. So we can use the exclusive OR gate to get the output of sum. The carry here only 1 is available. What is available here? 1 1. 1 1 means AB. A into B. Right? In order to get the carry, what is the expression? Binary expression is A into B. Right? So we can use the K map also for getting the binary inputs, the binary expression. See this K map available. For carry only one is there. Correspondingly here what we have? A, here B, right? So A is available vertically, B is available horizontally, 0 1 0 1, right? The carry available for 1 1, so that the expression is AB. Similarly sum, A is available vertically, B is available horizontally, 0 1 0 1. So two possibilities, right? 0 1 1 0. 0 1 means it is A bar B. 1 0 means it is A B bar, right? So A B bar plus A bar B. By using K map or directly we can write the expression. A B bar plus A bar B is nothing but the exclusive OR gate. A exclusive OR gate of B. Now we need to implement this with the logic gates, right? Carry is nothing but A into B. So what we need is AND gate. One AND gate is needed. Sum equal to A exclusive OR B. So here we need one XOR gate. We need a XOR gate here, right? For sum we need one XOR gate. For carry we need one AND gate. Now we'll see the logical diagram. So the logical diagram is available here. So this is the XOR gate is available. The two inputs are given A and B. So that what we'll get XOR gate output is A bar B plus AB bar. So this is nothing but the expression for sum. For carry what we need is A into B. So A and B is given to the AND gate. So we got AB, right? So by using XOR gate we got the output of sum. By using AND gate we got the output of carry A bar B plus AB bar. Then carry is AB, right? Now we'll see what are the limitations of this half adder. We already discussed that. Here only 2 bits are available, but in practically what we need is 3 bits, that is 2 input and carry. So in multi-digit addition we have to add 2 bits along with the carry, right? So practically only 2-bit addition is not enough. So because while adding the carry is generated, so we need to concentrate 2-bit addition along with the carry, right, of previous digit in addition. Effectively such addition of 3 bit is effectively such addition of these 3 bits. This is not possible with the half adder, because half adder will add only 2 bits, but what we need is 3 bits in practical, 2 inputs and carry. So that is the limitation of this half adder. Hence half adder is not used in practical, but using half adder we can construct the full adder. Full adder is constructed using half adders, right? So for that we are using this half adder, but practically it is not possible because it is adding only 2 bits. Practically what we need 2 bits along with the carry, right? So in this video we discuss about the addition. What is the addition in digital computer? What are the possibilities are available? And what is the difference between the half adder and full adder? Adding 2 bits and 3 bits. Right, we developed the truth table. Based on that we got the expression. From the expression the logic circuit is implemented. Finally we discuss the limitation of the half adder, right? Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.